Okay, this is going to be a real short add-on to 2.6. It's going to be the third video for section 2.6. And basically what I'm going to do here is I'm going to just show you how to graph a quadratic function and put everything together. So I'm just going to take a quadratic function here, f of x equals minus 2x squared plus 8x minus 2. And we're going to work through the graph. Now, the first thing you're going to want to do is you're going to want to get the vertex. So let me set that up. So here you know that a is -2 and b is 8. So to get the x value or the h value of the vertex, you just do minus b over 2a. So do minus -8 over 2 times -2. And that's actually -8 divided by -4, which is +2 here. And then to get the y value or the k value of the vertex, plug 2 back into this function. And so if I plug 2 in here, I get -2 times 2 squared. So that's just going to be -2 times 4. And then plus 8 times 2, which is 16. And then, of course, minus 2. And then you have -8. Multiply that together, you get -8 plus 16 minus 2. And -8 plus 16 is 8. And 8 minus 2 is 6. So the vertex is actually the point 2, 6. So that's the vertex. Now the axis is the value x equal 2. So let's pretend like this graph is not there for just a moment. And let's think about what I would need. I would actually need to draw the vertical line that goes through x equal 2. Okay, so that would be my axis of symmetry. And actually, let's draw it dotted. Let's not draw it solid. Again, I don't like you to think that that's part of the graph. And then what I would do is I would label this point right here. This point right here, this would be my vertex. Okay, that's the point 2, 6. So I would, count 2 to the right and up 6, and that's my vertex. So let's right now just pretend like we just have this vertical axis and this vertex plotted for now. And of course we know it opens downward because a is negative. Now also I said minimum here, it's actually maximum because it's opening downward. So my bad there. So that's really a maximum. Okay, so the maximum is y equals 6. Now, the y-intercept is 0, -2. You can actually see here that if you let x be 0, then this term disappears, and you get -2 for y. So that's easy to do. So 0, -2. So what you could do is, you label the point 0, -2. And now that we have this axis drawn, we would know that there's another point right over here that's symmetrical to that point 0, -2. So that allows. Now actually we could get a decent graph just from these 3 points. The vertex and these 2 points. Okay? But what I decided to do is I decided to go ahead and plug another point in. Now you'll see I got another point, but I'll show you how I got that. If I plug 1 in to this, well, I get -2 plus 8, that's 6, and then -2 is 4. So 1, 4 is a point on the graph. So I just go over to 1, 4 and I plot that point. Now, based on the symmetry, that's 1 unit to the left, so there must be another point over here 1 unit to the right. And that's how I got the point 3, 4. And actually, that's really all you need. You can actually, from those 5 points, you should be able to draw a pretty decent parabola that goes through here. And then, of course, you can also see, I shared some other information with you. The domain, like I said before, the domain of quadratic functions are all real numbers. And the range here is -infinity up to 6 because, like I said, you start way down here at -infinity. See, it goes down forever. And the highest it gets, forgive the stretchy graph there, but the highest it gets is right there at 6, and then it turns around and goes back down. But anyway, that's that's how you can graph this function without using technology, is basically getting the vertex, get the axis, make sure you know which way it opens, get your y-intercepts, plot some other points if you have to, and then just start connecting the dots, and you know the general shape of the quadratic function, and then all you have to do is draw it. So that's the end of the section 2.6 on quadratic functions. So the next video I'm going to cover has to do with another type of function, rational functions. I actually misspoke. The next video I'm going to talk about applications of functions. Then I'm going to talk a little bit about rational functions in the one after that. Have a good day.